Hello, mathematicians! How are you? I believe you are very eager to learn new things this week. I am Teacher Marietta, your partner in discovering the patterns involved in factoring polynomials and solving word problems. Get your pen, your answer sheet, and extra papers for your solution. All ready? Fasten your seatbelt, for we are about to begin. Our topic this week culminates the lesson on factoring polynomials. It is composed of two learning competencies merged for this week. Thus, you are expected to, first, factor general trinomials. In here, we will be discussing separately how to factor polynomials of the forms x squared plus bx plus c and ax squared plus bx plus c. This is labeled as Lesson 5 in your activity sheet. Second, you are expected to solve word problems involving factors of polynomials. This is labeled as Lesson 6 in your activity sheet. Let's start! Factoring general trinomials of the forms x squared plus bx plus c and ax squared plus bx plus c. Our guide questions would be, how do we factor general trinomials of the form x squared plus bx plus c? I crafted 3 easy steps to follow. First, we need to list all the possible factors of the last term. Then, write the respective sum. Let's have example number 1. Let's factor x squared plus 7x plus 12. In our example, the last term is 12, so the possible factors are 1 and 12 with a sum of 13, another 2 and 6 with a sum of 8, and 3 and 4 with a sum of 7. Second, choose the pair of factors whose sum is the numerical coefficient of the middle term. In here, the middle term is 7x. Therefore, from the given list of factors, we choose the pair 3 and 4. Third, we write the chosen pair in binomial form, the quantity x plus blank times the quantity x plus blank. The respective signs will serve as the operations. Remember, the chosen factors are 3 and 4. Since 3 and 4 are both positive, we use addition. Thus, the final factors are x plus 3 times the quantity x plus 4. If you like a shorter version, it can be done this way. Just look for the factors of the last term that will give a sum which is equal to the middle term. Consider same example above. X squared plus 7x plus 12. What about the factors of x squared plus 2x minus 15? The same process. Look for the factors of negative 15 that will give a sum of 2. What do you think is the best pair of factors? It is 5 and negative 3 because 5 times negative 3 is equal to 15. And when we add 5 and negative 3, it is equal to positive 2, which is the middle term. Therefore, the factors are x plus 5 times the quantity x minus 3 or x minus 3 times the quantity x plus 5. We can interchange the location of the factors as long as they carry with them the respective signs. You might be asking, why not negative 5 and 3? Yes, negative 5 and 3 are not the best pair because their sum is negative 2, which is not the middle term. I hope you understand. What about if the middle term is negative? For example, x squared minus 9x plus 18. Same process. Think of the best factors of 18 that will give a sum of negative 9. The factors are negative 3 and negative 6 because negative 3 times negative 6 is equal to positive 18. And when we add negative 3 and negative 6, the sum is negative 9, which is the middle term. So, the factored form of the given polynomial is equal to the quantity x minus 3 times the quantity x minus 6. So that you will understand more why we use negative 3 and negative 6, look at these other pairs of factors of 18 and the respective sum. Among these pairs, as you can see, nothing gives a sum which is equal to negative 9, which is the middle term. Is it right? This is why it is very important to choose the best pair of factors. Just like in your love life, you need to be very careful in choosing your best pair. Look for that someone whom you think will help you meet your future goals in life. Just a friendly reminder, if you cannot think of factors of the last term that will give a sum equal to the middle term, then the trinomial is prime or not factorable. Look at this example, x squared plus 2x plus 10. If you look at this, we cannot think of factors of 10 that will give a sum of 2, right? If you are thinking of 5 and 2 as factors of 10, the sum is actually equal to 7, and it is not 2. Therefore, x squared plus 2x plus 10 is prime. Other examples of prime trinomials are x squared minus x plus 5, x squared plus 5x minus 3, and others. Can you follow the given examples? If things are still cloudy on your part, you can always contact your math teacher. I hope the given examples are clear so we can proceed to our next subtopic. What about the trinomial of the form ax squared plus bx plus c, where a is not equal to 1? How do we factor trinomials of this form? In your learning activity sheet, I have presented two methods there, the trial and error method and the AC or the grouping method. However, in this video, I am going to present only the AC or the grouping method. It's something long, but at least from the steps, you can immediately determine where you committed an error. I have here 3 examples. Example 1. Factor 3x squared plus 8x plus 5. Here are the steps. First, we multiply the first and the last terms, which are 3x squared and 5. That's why it's called AC method, because as you can see in this step 1, we multiply the values of A and C in our pattern ax squared plus bx plus c. Next step, find the factors of 15x squared, which is actually your answer in step 1. That will give a sum of 8x, which is the middle term. We choose the factors of 15x squared, which are 5x and 3x. This is because 5x plus 3x is equal to 8. Step 3. Let's rewrite 3x squared plus 8x plus 5, which is the given, into 4 terms by replacing 8x, which is the middle term, using the factors identified in step 2, which are 5x and 3x. So 3x squared plus 8x plus 5 becomes 3x squared plus 5x plus 3x plus 5. Next, we group the terms with a common factor. In our polynomial, we'll group 3x squared and 3x together, and 5x and 5 also. Step 5. Let's factor out the GCF in each group. In the group of 3x squared plus 3x, the GCF is 3x. So, we factor it as 3x times the quantity x plus 1. This is actually applying your lesson 1. In the pair of 5x plus 5, the GCF is 5. So we factor it as 5 times the quantity x plus 1. To make sure that your factors are correct, check by multiplying 3x and the quantity x plus 1 if it is equal to 3x squared plus 3x. You do the same with 5 and the quantity x plus 1 if it is equal to 5x plus 5. And the last step, let's factor out the common binomial in step 5, which is x plus 1, or we just write this as one factor. And then pair 3x with 5 or positive 5. Therefore, we have the quantity x plus 1 times the quantity 3x plus 5. These are the final factors of the given trinomial 3x squared plus 8x plus 5. If it is difficult for you to follow the steps, as I have said earlier, you can always contact your teacher or pause the video or review the part of the video where you find it necessary. Another example, let's factor 2x squared minus 7x plus 3. So we follow the same process a while ago. First, we multiply the first and the last terms. The product is 6x squared. Next, we find the factors of 6x squared with a sum of negative 7x, which is actually the middle term. So the factors are negative 6x and negative 1x. This is because if we are going to add negative 6x plus negative 1x, the result is negative 7x, which is the middle term. Step 3, let's rewrite 2x squared minus 7x plus 3 by replacing negative 7x by the factors, which are negative 6x and negative 1x. These are the factors that we have obtained in step 2. So from here, 2x squared minus 7x plus 3 becomes 2x squared minus 6x minus 1x plus 3. So for step 4, let's group the terms with a common factor. From our answer in step 3, pair 2x squared and negative 6x. Then after that, we also pair positive 1x minus 3. In here, negative 1x plus 3 was changed to positive 1x minus 3 because we brought outside the negative sign. Then step 5, let's factor out the GCF in each pair. In the pair of 2x squared minus 6x, their GCF is 2x. So the factor will be 2x times the quantity x minus 3. In the pair of 1x minus 3, the GCF is 1. So it becomes negative 1 times the quantity x minus 3. And for the last step, let's write the quantity x minus 3 as one factor, or we copy the common factor obtained in step 5. And then after that, we pair the outside factors, which are 2x and negative 1. Therefore, the final factors are the quantity x minus 3 times the quantity 2x minus 1. Okay, let's have one more example. As they say, the more examples, the better. So this is what we are going to do. You are going to fill in the missing part. Then after 3 seconds, the correct answer will be shown in color red. Let's factor 5x squared plus 2x minus 3. We follow the same process. First, we multiply the last terms. So in here, it will become 5x squared times blank is equal to negative 15x squared. What will be your answer there? You're correct. Negative 3. Okay, step 2. Let's factor your answer a while ago, or negative 15x squared. That will give a sum of positive 2. So in here, the factors should be blank and negative 3x. The answer is 5x. Very good. Next step, we are going to rewrite 5x squared plus 2x minus 3 as 5x squared plus blank minus 3. The correct answer is plus 5x minus 3x. Next, we group the terms with common factor. The first group will be 5x squared plus 5x and negative 3x paired with blank. Okay, so the correct answer is negative 3. Step 5, we factor each term. The first pair will be factored as blank times the quantity x plus 1 minus blank times the quantity x plus 1. What do you think are the GCF there? Okay, we have the first GCF is 5x and the second GCF is 3. Very good. And the last step, let's write the quantity x plus 1 as one factor. Then after this, we are going to pair 5x and blank. Yes, negative 3. Okay, from our steps, we can say that the factors of 5x squared plus 2x minus 3 are the quantity x plus 1 times the quantity 5x minus 3. Very good. This ends lesson 5, which is factoring general trinomials. I hope you are already armed with the proper techniques on how to attack trinomials. Now, we connect our lesson to real-life scenarios. Did you know that algebra is a tool to explain geometry? In the same manner, geometry gives life to algebra. Let's proceed to lesson 6, which is solving real-life problems involving factors of polynomials. Problem number 1. The area of a square wall decor of Zagman is 144 square inches. Find the length of each side. First, we should identify what are the given known or the given facts in the problem and what is the unknown. In our problem, the known is the area, which is equal to 144 square inches. The unknown is the length of each side of the picture. Next, we represent the unknown using the letters or variables. So, we let x be the length of each side. Then after this, we formulate our equation basing from what is being asked in the problem. Since it was mentioned that the figure is a square and the area is given as 144 square inch, we use the formula A is equal to S squared. We substitute the given area, which is 144. Therefore, the new equation will be 144 is equal to x squared. We now solve what is being asked. Find the length of each side of the wall decor represented by x. We can actually solve this in many ways. Just like in our real life, we have different ways and preferences on how to solve a certain problem. What is more important is we attain the best result. In this case, A is equal to S squared becomes 144 equals x squared. We apply symmetric property of equality. We interchange the location, so it becomes x squared is equal to 144. From this, we subtract 144 on both sides of the equation, so we have x squared minus 144 equals 0. If you notice, this new equation falls under the topic factoring difference of two squares with the pattern x squared minus y squared is equal to the quantity x minus y times the quantity x plus y. So, x squared minus 144 equals 0. This is factored as the quantity x minus 12 times the quantity x plus 12 equals 0. Since we are solving for the value of x, which stands for the measure of the side, we equate each factor to 0. We have x minus 12 equals 0 and x plus 12 equals 0. In each equation, we solve for the value of x. Applying the shortcut, we transpose negative 12 to the right side of the equation and change its sign to positive. Therefore, x is equal to 12. Similar to the second equation, we transpose positive 12 to the right side of the equation. So it becomes x is equal to negative 12. Do not forget that when you transpose a certain number or a certain term to the other side of the equation, always change the sign to its opposite sign. If we connect this to our real life, there is no negative measure. We cannot say that your height is negative 5, or we can also say that your weight is negative 56 kilograms. It's similar in this problem. So, x is equal to negative 12 is rejected. Therefore, we can say that the measure of the side of the square wall decor is 12 inches. You can always check if your answer is correct by substituting the solved value to the given equation. Is the problem clear? Okay, let's have problem number 2. The area of a tuping or stone wall of Uncle Pitayan's rice field is labeled as 2x squared plus 7x plus 6 square meters. The questions will be, if its width is represented by x plus 2, what is its length? The given in the problem that may help us are, first, the area, which is 2x squared plus 7x plus 6. Second, the width, which is represented by x plus 2. And third, the shape, which is rectangle. So in here, the unknown is the measure of the length. From the given, we can formulate our equation patterned from the formula in solving the area of a rectangle, which is A equals L times W, or length times width. Substituting the given area, we have 2x squared plus 7x plus 6 is equal to L, or the length, times x plus 2. We factor the area 2x squared plus 7x plus 6 as x plus 2 times the quantity 2x plus 3. This is actually applying our latest lesson, which is factoring general trinomials. Then after this, divide both sides by x plus 2 to solve for L. Or we cancel x plus 2 and x plus 2. And also on the other side. So from here, L, or length, is equal to 2x plus 3. Therefore, the length of the rectangular stone wall is represented by 2x plus 3. The next question is, what is the actual dimension of the rectangular stone wall if x is equal to 3 meters? When we say dimension, this means the measure of the length and the width. So to answer the question, we simply substitute the given value of x, which is equal to 3, to the width and the length. So first, as it was mentioned in the problem, the width is represented as x plus 2. Therefore, W equals x plus 2. We substitute x, which is 3. So we have 3 plus 2. Then if we add this, the result is 5 meters. Next, we solve the actual measure of the given length. We use 2x plus 3 as solved earlier in the first question. So L is equal to 2x plus 3. The same process, we substitute x, which is 3, so it becomes 2 times 3 plus 3. So 2 times 3 is equals to 6. Added to 3, the result is 9 meters. Therefore, the actual dimension of the rectangular stone wall is 9 meters by 5 meters. The concept learned in this video can also be used to solve problems related to number relations. Take a look at problem number 3. It says here, the square of a number decreased by 36 is equal to 64. Our task is to find the numbers. From the problem, the given is the square of a number decreased by 36 is 64. The unknown is the actual numbers involved in the problem. From here, we represent the unknown as x and the phrase square of a number as x squared. The equation will be x squared minus 36 is equal to 64. This is because it says in the problem that the square of a number, which means x squared, decreased by 36 means minus 36, and the word is means equals. Now, to solve x squared minus 36 is equal to 64, we apply the subtraction property of equality. This was discussed in your grade 7. So we subtract 64 on both sides of the equation. It becomes x squared minus 36 minus 64 is equal to 64 minus 64. From here, negative 36 minus 64 is equal to negative 100. And 64 minus 64 is equal to 0. Therefore, the new equation is x squared minus 100 equals 0. We can also factor this using the difference of two squares, or the pattern x squared minus y squared is equal to the quantity x minus y times the quantity x plus y. From here, the factors will be the quantity x minus 10 times the quantity x plus 10 equals 0. To solve for x, we need to equate each factor to 0. So we have x minus 10 equals 0, and also x plus 10 equals 0. To solve for x, we transpose negative 10 to the right side of the equation. Therefore, x is equal to positive 10. The same with x plus 10. We transpose positive 10 to the right. It will become x is equal to negative 10. Therefore, from our solution, we can say that the numbers are 10 and negative 10. In here, we can accept both the positive and the negative values because we are talking about numbers and not measures. To check if your answers are correct, we substitute the solved values of x to the given equation. If the left and the right side of the equations are equal, then the answers are correct. So let's check using x, which is equal to 10. From our equation, x squared minus 36 is equal to 64. We substitute x, which is 10, so we have 10 squared minus 36. Is it equal to 64? 10 squared is equal to 100 minus 36 is equal to 64. So from here, we can see that the left and the right side of the equation are equal. So therefore, our answer, which is x equals 10, is correct. Let's check the value of x, which is equal to negative 10. The same process. We substitute the value of x, which is negative 10. So we have negative 10 to the second power minus 36. Is it equal to 64? The quantity negative 10 to the second power is equal to 100 subtract 36. The result is 64. Therefore, we are very confident that our answers are correct. That's all for today, class. I hope you learned something from all the examples that were given. Here is a summary of all the patterns involved in the 5 factoring techniques which were discussed for these 3 weeks. You can take a photo of this or pause the video and copy it in your math notebook. That's all, class, for this week. I hope you learned something from this video. Do not forget to answer the activities found on pages 7 and 11 of the given learning activity sheets. Before we end, here are some points to remember in factoring different types of polynomials and its application to word problems. Number 1, in factoring, always check if there is a GCF before applying other factoring techniques. Number 2, always do the checking procedure to check if your answer or factors are correct. Number 3, in solving word problems, be very careful in forming the equation. This is very important because once the equation is wrong, everything will be wrong. And in number 4, in solving real-life problems, disregard the negative values. Remember, there is no negative measure. Just like in our life, we should learn how to alter our negative mindset and all the factors that hamper us to learn. Don't worry, mathematics always gives us the hope that in every problem, there is always a solution. That's all for today. See you again in the next episode. Only here at DepEd MP TV.